Hey guys, welcome to my channel. In this lesson, we're going to learn the difference between a linear and exponential functions. And let's start with this key point. It's actually something that you will learn at the beginning of Algebra 1, and that is that a linear function is a function whose graph is a line. Linear function, line. Pretty easy. Now, this line cannot be vertical. That means that my line cannot be a vertical line. This is not it's not a linear function. It's not a linear function, okay? Now, a linear function has a constant rate of change. This is also known as a slope. We know that the constant rate of change is the same thing as a slope. And it can be represented as a linear equation in two variables. Now, the slope-intercept form of a linear equation is y equals mx plus b, where m is a slope, b is a y-intercept. And usually, if you look at a table or at a graph, it looks like as x is changing by 1, y is also changing. And it looks like you're either adding or subtracting a number. So here's a few examples. Let's figure out whether these tables show a linear pattern or a non-linear pattern. For that, the only thing that I have to look at is the values of y and analyze how the values of y are behaving. How are they increasing? So let's start with letter A. So I have -1, 2, 5, and 8. If you notice, every single time, these values are increasing by 3. By adding 3. Because my y's are increasing by adding 3 every single time, that means that this table shows a linear function. Let's take a look at letter C. Letter C goes from 2 to 10 to 50 to 250. Notice how quickly this is growing. Most times, this will tell you that your equation or your function is nonlinear. But let's figure out why. Let's figure out why this is nonlinear. Well, how did I get from 2 to 10? I know that I can add 8, but that is not really going to work on the second one, so I have to think about something else. Another way that I can get from 2 to 10 is by multiplying times 5. Same thing happens here. From 10 to 50, I can also multiply times 5. And from 50 to 250, I can also multiply times 5. Because here, I have what I call a common ratio. This is a common ratio. My function is nonlinear. What I recommend right now is that you try letter B and letter D and see if you get it right. So pause the video at this time and see if you can get letter B and letter D right. Okay, hopefully you pass the video, and you must have noticed that letter B is also linear because every time it's increasing by 5. This is what we call the common ratio. I'm sorry, not the common ratio, but the common, not common. I keep saying it wrong, I'm sorry. It's a constant rate of change. If it's adding or subtracting, we call it a constant rate of change. Therefore, because it has a constant rate of change, this is linear. And then on this one, it's a little bit harder to see because all I have is negative numbers, but all you're doing is multiplying times 3. times 3 times 3. Because I have a common ratio, and the common ratio is 3, this function is non-linear. That's it for today. If you enjoyed this video, please subscribe to the channel. More videos are coming.